Alright, this is a video for 2.8, which is graphing inequalities. Before we jump into graphing inequalities, I do want to review quickly how to graph some equations of lines, just so we have that out of the way before we start making it a little trickier. So in case you haven't, or you have forgotten, y equals 4x minus 3. We have a y-intercept of negative 3. So we're going to start at that y-intercept down at negative 3. I'm going to label my axis here, go by ones, and then a slope of 4. So we go up 4 and right 1. So just a little warm up here, and then if I had a ruler, I would totally use it. Graph that line. Okay? When we're given in this middle one something in standard form, best practice usually is to use that to find the x-intercept and y-intercept. So I'm going to take x-intercept. So I take y out of the equation and I solve for x. So I'd have 2x equals 18. Sounds like a y, or an x-intercept, sorry, of 9. Y would be 0. Y-intercept is going to take x out of the equation, so that would give me a negative 3y equals 18. You divide and you get negative 6. So those are my two intercepts, and I will absolutely graph those right now. 9 on the x-axis, negative 6, sorry, on the y-axis. And again, if I had a ruler, I'd use it, so yeah, that's getting worse. Sorry about that. We'll just try it once, and it's mostly straight. Okay, graphing that line. I find every year that students are very tricked by the equations like y equals 4 or x equals 7, things like that. Please don't let those trick you. They are just special lines. Y equals 4 happens to be horizontal, so I'm going to label my axis here. And y equals 4 is just a horizontal line up at 4, so it crosses there. And you would think I could trace the line, but I can't. That's the line y equals 4. Okay, x equals a number would just be a vertical line at whatever number that is. So keep those things in mind. Don't forget those special things, types of lines. Okay, now jumping into 2.8, we're going to basically graph lines and then do some shading. So a couple things that we need to keep in mind. For a less than or a greater than, we're going to use a dashed line, okay, dashed or dotted. And then for the less than or equal to or greater than or equal to, that gets to be a solid line like we were just using. So you do have to keep in mind whether you're solid line or dashed line. And then to determine where we shade, some people just do it based off of whether it's less than or greater than. I always like to check a point that's not on the line. If it's true, you shade over it. If it's false, you have to shade on the opposite side. That way never has failed me, works every single time. The other way can get a little tricky, especially if you forget to flip the sign at some point in time. So let's graph and see what we can figure out. So this first one, I have y less than 2x. So I'm going to think about the graph of y equals 2x. So it's a slope of 0, or sorry, a y-intercept of 0, and a slope of 2. So I'm going to go up 2, right 1. I can do that again if I want to. Label axis. You're probably going to want graph paper for these assignments, so I have some copied in the classroom if you want to come and grab a couple sheets. Okay. This is a less than, so it's a dotted line. I'm going to go snag my dotted line tool and sketch that in for you. Should have used that before. And now I get to figure out the shading. Okay, you can pick any point on either side of the line, just can't go through the line. So I'm gonna pick like a test point over here. Maybe I use this yellow dot over there as my test point if I wanted it. That's a negative 3, positive 2. So I just plug it in. And is negative 2 less than negative 6? No. So we would shade on the opposite side, and you don't need to shade in very heavily or anything like that, just indicate that you've checked. Okay? Awesome. Next one, x less than or equal to 6. Okay, I might actually do my scale by 2s this time. So I'm going to label that. And then x equals 6 is the graph I'm going to sketch. So x equals 6 is a vertical line and crosses the x-axis at 6. So I'm going to go grab my line drawing tool, solid line because it can equal that, and I get that line right there. Then I shade less than. I like to choose the origin when my graph doesn't go through the origin. So I'm going to choose origin. 0, 0. Is 0 less than or equal to 6? Yes. So I'm going to shade over there. Okay. The next one, standard form, looks like I can definitely use intercepts to graph that. So I'm going to find my x-intercept, take y out, and you get 5. Y-intercept, take x out, and you get -2. So axis, both of them by 1s should work. A 5, 0, and a 0, -2. It is a less than or equal to, so I'm going to keep my solid line, and I'm going to draw my solid line through those points. Again, this one does not go through the origin, so I'm going to go ahead and just use that origin as my test point. And that gives me 0 minus 0, which is 0, greater than or equal to 10, false statement, so I can't cover that up. I jump across the line and shade down over there. All right. The last one reviews graphing absolute value functions, so we want to keep in mind where the vertex is. Okay, vertex is at the HK, so we have H and we have K. So a vertex is 3, 1, and then we want to keep in mind the slope of the right-hand side. Okay, and that's going to be our A value, which is 2. So I'm going to find the point 3, 1, and I'm using a scale of 1 again, so 3, 1, and then the slope of the right-hand side is 2, so I'm going to go up 2, right 1, and maybe one more time. But we know that this has to be V-shaped, so to find the other side, I'm going to go up 2 and now left 1, up 2 and left 1, so I can get that V shape. Okay, back to my lines. This was a less than symbol, so it will be dotted. So I'm going to dot my line, go there, and I'm going to dot my line and go this direction. Notice the arrows are only up on the top. And now to figure out shading, I can pick a point. 0, 0 again is a great idea. As long as your line doesn't go through it, it's the easiest. So if we do 0 for y, I'm going to have 2 times the absolute value of -3 plus 1. Well, absolute value of -3 is 3 times 2 is 6 plus 1. 0 less than 7 seems legit. So we're going to shade everywhere outside of that absolute value. Okay, I hope this helps you graph some inequalities.